I'm going to explain about flow over immersed body. So, an object moving along the flow has a resultant force between interaction of the body itself and the flow. So there are two kinds of force. The force that move the object vertically and horizontally. So there are lift force overcomes weight of the object, and drag force which holds the thrust of the object. So an object could move forward if the thrust is bigger than the drag force. What is drag force? So drag force is a force created by this flow that move over the body. So this is a body, and when a flow moves along the body, it has vortex. So this vortex act like when you see a parachute. The parachute will makes you slower when you went down to the ground, right? When parachuting. So same like vortex, it applies same principle, same theory as the parachute. That's the vortex actually. So it makes you backward actually. No. So shape of the object determines how big is the drag. How big is drag force. So as you can see, this is streamlined body and this is unstreamlined body. Streamlined body has a smaller vortex than the unstreamlined body, bigger vortex. So as I told you before, the vortex acts like a back pressure, so it holds you to move forward. So if there's a force, this vortex like move you backward. So the drag force is a force created from this situation. So if this is a car, so if a car has the same output, this has the same engine, same output, like 100 horsepower, and because of the drag force created from the shape of the car, the streamlined car will have less drag force, so the engine will move, the car will move more efficiently than the unstreamlined car. I will explain about lift force. So lift force is a force that moves an object upwards. So a lift force must overcome the weight of the object to make the object move upward. So where does the lift force come from? So as you can see, this is the shape of an airfoil when it goes upwards. So this is a streamline. So as you can see, the streamline that move along the bottom of the airfoil is being diverted because of the angle of the object itself. So when the the velocity is being blocked by the airfoil is being diverted right here, right? So velocity is become lower. When the velocity lower, the pressure is higher. So the bottom part of the airfoil has bigger pressure than the upper part. So bigger pressure means bigger force, right? So because it has same area. So if pressure created in the bottom of the airflow will move upwards. That's the lift force. I'm going to explain about flow in pipes. So there are many applications of piping. So if you want to deliver oil from point A to point B, you would use a pipe, usually a big pipe. So yeah, there are many applications of pipes, but you can't see what's inside the pipe, right? So because the pipe, unless it's transparent pipe, so you could see what's inside of them. So actually there are three types of movement inside the pipe. First is laminar and turbulent, and between them is transitional. What is laminar? Laminar is when the fluid inside the pipe is moving steady, like constantly, without any boundaries whatsoever. But turbulent, the flow moves like wavy, like something blocks them inside. So how do we determine that a pipe have this kind of movement? We determine it by Reynolds number. Reynolds number is a ratio between its density, volume, dimension, and this is a friction ratio. So how do we determine this kind of movement? It's by this Reynolds number. So it's basically a ratio between the density, a velocity, dimension and diameter from here right here, and a friction between the flow and the pipes itself. So here will be a friction because that's why this velocity of water of a fluid near its pipe wall will be lower because of the friction of the pipe itself. In the center of the pipe is the highest velocity, so the flow will be flow much faster if it's located in the middle of the pipe. So as you can see, if the laminar is a pipe where the Reynolds number is below 200,000, and the turbulent is above 4,000. So transitional is between 2,100 and 4,000 over Reynolds number. So I'm going to explain about compressible flow. Compressible flow is a flow that has change in density. So as we know, density equal or rho. Density equal pressure per RT. So how do we relate this into something like flow in pipes, maybe? So if we have converging pipes, so the flow travel in a certain velocity, when they reach this area, this converging area, the velocities become lower, right? Hence the pressure right here is greater. So pressure is greater, and when the pressure is high, when the pressure is increasing, the density is also increasing. So this kind of flow, we name it compressible flow because it has change in density in this system. What is Mach number? Mach number is a velocity per speed of sound. So speed of sound is actually distance traveled per time. So it's a velocity of a sound wave through a medium. So speed of sound is like if there's if it's a medium like water or air, it's a particle of air. So is there if the sound wave, the sound wave will travel through a medium, like to a particle per particle. So it's how we define the speed of sound. So if a velocity is so greater that it is so if a velocity is so high, so as high as the speed of sound, so because if there's a velocity, and in the ground the speed of sound is also 340 meters per second. So this is equal 1, right? Speed of sound, so Mach number, if Mach number reach 1, so the object that reach Mach number 1, it is already in supersonic condition. That's why if we see an airplane through a speed of sound, it will like a barrier around it, right? So actually, this is a so the airplane that's traveling so fast, the air around it is not capable of disperse going away, like flowing through the air, but it's like when you move your hand against water, the water is not moving through your hand, right? So it's becoming like a wave. So that is speed of sound.